in a good way. This is the way we plan to do it, because we have an old wind turbine. When we are ready with our setup system, hopefully in a couple of months, we will have this system in operation. We have our old wind turbines, that's the size of 30 kilowatt and 40 meter diameter, 30 meter high, wooden tower, and we control everything ourselves. So we make the control ourselves. So if your students like to test your control you talked about before, you're welcome. I think that's quite unique opportunity to have your own wind turbine to play with. That's quite fun. So welcome students. And we have a battery system. We have it coming from electric vehicles, electric cars, batteries that has been taken out of the cars. Green forming converter, transformer, and up to that. And we have a load and solar panels also. And we have nodes that we control. I thought when we started this project that new batteries has more or less a constant voltage, but that was not the case. So this is the voltage change of the battery, voltage one set of the batteries. It goes from here roughly up to here. So this is the number of that one. So it's 15% variations. We don't use the last 10% of the sock level or the lowest 10%. So just to keep the battery more stable in voltage. We use 488 cells, new ones. This is the energy in the battery. Typical for a car, a little low for a car today. The green forming converter is designed by ourselves, so we have these voltage levels. If you have 500 volt DC in, then it's hard to get 400 volt out AC. So then we need just the 300 volt out AC. And we use the transformer to increase the level. So this is what we have managed to test in the lab up to today. We have the solar power there. We have a DC machine that is the battery in our lab. The green forming converter and the control, transformer and load. This is the control of the green forming converter. I will not go in detail. Then you have to read your PhD thesis from our university. But anyway, there is a true control of the frequency. So it's changed by load. Not so much, but half a hertz or something like that. And the voltage is quite stable, depending on that's the way the control is designed. And that is the typical normal control of the converters. Everything is developed in Simulink program. Then implemented the Gs.Ts system and connected to the converter. So this is the battery case. During construction, there are some wires still needed there. This is the converter that we have built ourselves in the lab, so we can play with as we like. And the Gs.Ts system connected, as I said. This is just a picture of the filter with coils and capacitors and power supply for measurement of voltage. So what we did, we just start up the control. And the guys that the converter, the transformer, connect the load. And then we have what I think quite nice voltage wave shape there. And then we make a loop step, a quite big one, 30%, 36% of the rated power. And then we can see how the active power is here, and then we just increase. And yeah, it can't be done better, I would say. And the water current is good, it's just directed to the new value. So it's smooth stuff. And as I said, the frequency changed with the load. It put down, what is the here? 0.3 hertz roughly.
Nhìn đau mắt quá.
So extremely fast response to the load. Stable reactive power the whole time. And I think very small disturbance. Nice work. And there was some failing during the startup. So we could go from zero to full loop in a proper way also. That was not meant to test it. Let's have it first. The efficiency of the system from DC into AC out is roughly 90%. I think that's quite okay for this kind of small system. The big system has at least 5% better efficiency. And this is our wind turbine. A direct driven generator designed from the University of Durham in England. Not so good. Anyway. Okay, the laboratory tests shows good performance, stable operation. And next step is we are right now doing the installation with the wind turbine. We developed the operation of the control of the wind turbine so that it can work together in a proper way. Hopefully we'll have the system up and running in December. And the control shows if the wind is heavy and the load is not so high, we start to charge the battery. But after a while the battery will be fully charged. Then we have to decrease the power from wind turbine in a proper way by pitching the blades. So that will be one small challenge to do that in a proper way. And more, it will be nice to see how the frequency converter of the wind turbine will be connected to this reforming converter for the first time also. If there will be some interruption there or not, that will be future seen because it's a big converter to not so big load can be a little risky. Hope there will be no frequency in the filters and so on either. Sure. So yeah, we have an interesting winter in Helms. So thank you.